Playing games is really fun. So let's imagine you go to a fairground and you come across a stall and there's a man standing there and he says, if you give me £1, I'll let you play a game. And if you win that game, well, I'll give you anything you want. So it could be a PS5, a brand new bicycle, whatever you want. But you're not really the gambling type. Instead, what you'd like to do is work out, do you have a good chance of winning the game? And if you work out that you have more than a 50% chance of winning that game, you decide to play. However, how are you going to know whether or not you have a 50% chance or more of winning that game? That's where dual probability comes into play. Okay, so dual probability. This man says to you, I have a sack of balls and I have this die here. Now, in the sack of balls, I've got 2 red balls, 1 blue ball, 1 yellow ball, and 1 green ball. And of course, on this die, it's a standard one. So it's got numbers 1, 2, 3, 4, 5, and 6. And he says to you, if you pick a green or yellow ball and roll a 5, you can have anything you want, any prize that you can dream of. So your job is to work out, do you have a 50% chance or more than a 50% chance of winning that prize? Now, let's see how we work this out. So my first step is to create a table that looks a little bit like this. Across the top, I'm going to put the numbers of the dice. So I'm going to put number 1, number 2, number 3, number 4, number 5, and number 6. And down the side here, I'm going to put the colors of the balls. Now we have got 2 red balls. So I'll write R and R for red, B for blue, Y for yellow, and G for green. So down the side, I've got the colors of the balls, and across the top, I've got the numbers of the die. Now, it doesn't matter if you put the colors of the balls at the top and the number of the dies down the side. I prefer to put the object with the most possibilities along the top because I like things to go long ways. I think they look neater. Okay, so how do we work this out? Now, you need to be able to pick a green or a yellow ball and roll a 5. So if I go down to green and go across to 5, this is a winning combination. But also you can pick a yellow and roll a 5. That too is a winning combination. However, there are no other winning combinations here. So with all of the other outcomes, so red and 1, red and 2, red and 3, and so on, I'm just going to put a dot. Okay, so bear with me while I do this. What I'm doing now is I'm marking all of the undesired outcomes, all of the outcomes that we don't want, because if we get these outcomes, we're not going to win the game. Okay, so look what I'm left with. I'm left with 2 outcomes that I want, and I'm left with, well, if I count all of the outcomes together, so that includes the outcomes that are desired and the dots that are undesired, how many outcomes are there altogether? We've got 6, 12, 18, 24, 30. We've got 30 outcomes that it could possibly be. Okay, so that's my bottom number. So my fraction, my chance of winning is 2 over 30. Okay, so we want to convert this into a percentage to see whether or not it's worth playing this game. So 2 over 30, let me clear my screen. I'm now going to rewrite 2 over 30. Now what I'm going to do with 2 over 30 is I'm going to simplify it, just so it's an easier fraction to deal with. So if I divide both numbers by 2, they're both even numbers, so I know that will work. I'm left with 1 over 15. So 1 over 15 means exactly the same as 2 over 30. Okay, so what I'm going to do now is change this into a percentage. Now, the way I do that is I'm going to first change it into a decimal. So here is a bus stop. I'm going to do the numerator divided by the denominator. So 1 divided by 15. Now, how many times does 15 go into 1? Well, of course, it doesn't go into 1 at all. It's bigger than 1. So I'm going to put a 0, decimal point, decimal point. I'm going to carry that 1 over because I've done nothing with that 1. I've not broken it down at all. So I've got to carry it over. But now I can add a placeholder. Now, how many times does 15 go into 10? Once again, it doesn't go, does it? 15 is bigger than 10. So once again, we've got 0. And I'm going to carry the 10 over. But this time, add another placeholder. So I now have 100. How many times does 15 go into 100? 15, 30, 45, 60, 75, 90. It goes in 6 times, but we land on 90, which means I've got a remainder of 10. How many times does 15 go into 10? Well, remember, when we carry a number over, we must add a placeholder. So the real question is, how many times does 15 go into 100? 15, 30, 45, 60, 75, 90 is 6, isn't it? Just like it was the last time, okay? So I know once again, because I landed on 90, I've got that 10 remainder, and I know that I need to add a placeholder. So once again, how many times does 15 go into 100? We know the answer 6, but I'm going to stop now because I've got 4 decimal places, and that's enough to work with. Okay, so my answer in decimals is 0.0666. Okay, so now what I need to do is I need to convert this into a percentage to see if it's worth playing that game. So how do I convert this into a percentage? I multiply it by 100. And we know what we need to do when we multiply by 100, sorry. I need to move each digit to the left twice. And that's going to give me 6.66%. Okay, so we can see that our chances of winning this game are 6.66%, which means we don't have a great chance of winning this game. Let's keep our pound. Let's not gamble it. We're probably not going to win. Okay, so I hope that made sense. Let's just have a look at one more. What about if he said to you, fine, we won't do the first game, we'll do this game instead. You can pick a yellow ball and an even number. If you can get a yellow ball and an even number, then you win the game. So we'll do the same thing as we did last time. Across the top, I'm going to put the numbers of the die. So 1, 2, 3, 4, 5, 6. And down the side, I'm going to put the balls that I'm using. So I've got red ball, blue ball, yellow ball, green ball. Okay, so what is the probability of picking a yellow ball and rolling an even number? So we've got yellow here, but 1's an odd number, so that wouldn't be correct. But 2's an even number, 3's an odd number, 4's an even number, 5's an odd number, 6 is an even number, okay? And all of the others, of course, these are outcomes that we don't want or we won't win the game. Okay, so let's see what we are left with. We have 3 outcomes that we'd like to see, but we've got a total of 30 potential outcomes. Okay, so 3 over 30, let's simplify that. I can divide both of these numbers by 3. So that becomes 1 over 10. So I've got my fraction. Let me clear the screen. Let's rewrite the fraction over here. 1 over 10. I have a 1 in 10 chance of picking a yellow and rolling an even number. But let's convert that into percentages. So let's do it the same way we did last time. Let's start by converting it into a decimal. So we've got 1 divided by 10. Now, how many times does 10 go into 1? It doesn't go. So I write a 0, a decimal point, carry the 1 over, sorry, the 10 over. The 10 over. And then this time add the placeholder, okay? How many times does 10 go into 100? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You could probably do that in your head. The answer is 10, and it's a perfect 10. There's no remainders. So the answer here is 0.1 or 0.10. Okay. So we've got our decimal. Now we need to multiply 0.10 by 100. So all we need to do is move each of these digits to the left twice. And when you've done that, you should end up with 10%. So you have a 10% chance of winning the game this time. So it's still, the chance is still not enough. So you're not going to have a go at this. But are there any, I mean, what could the this man say to you to make you play? Are there any combinations which will give you a really high chance of winning the game? What about these combinations? What is the probability of picking a blue ball and rolling a 4? What is the probability of picking a red ball and rolling an even number? What is the probability of picking a red ball, a blue ball, a yellow ball, or a green ball and rolling an even number? So have a look at these questions. See if you can work out your chances in percentages and see if any of these scenarios are scenarios which are likely to make you part with your money and have a go at the game. What do you reckon, guys? Give this a go. Thank you very much for watching. Goodbye.